The Christmas season is approaching, and nothing is better during the holidays than the food, the gifts, or to other countries, pastel. In Filipino households, mango graham cake is notorious during the holidays or even any event. The way we arrange our graham cake is the same way how we arrange the gifts under the Christmas tree or how the snow falls from the sky. The ones on the bottom are the old ones. The first graham you lay, the first gift you pick, or the first snow that fell, while the ones we put the latest are the new ones. This analogy can show us how stratified rocks are formed. Take a look at this. This is another demonstration of stratified rocks. Let's assume that this is a rock. As you can see, it is composed of different layers or beddings. But before we go deeper into explaining what these layers are, let us first find out what is a stratified rock.
A stratified rock is basically a sedimentary rock. Stratified rocks are known for their beautiful arrangement of horizontal layers called strata. Layered rocks can be seen everywhere, and surprisingly, they are naturally arranged this way over time in a process called stratification. But what exactly happens during stratification? And how are stratified rocks really formed?
First thing that happens in the formation of stratified rocks is the exposure of an old rock to wind and water. Due to this exposure, the rock will break into pieces and these particles would settle to the bottom of river, lakes, and oceans. According to the study of Danish scientist Nicolas Steno, the weight or size of particle affects the time it would settle from a fluid. Largest and heaviest particles would settle first, and lightest and smallest particles would settle last. For example, I have here a rock weighing 20 grams and another rock weighing 10 grams. Which do you think would settle first? Of course, expect that the rock weighing 20 grams would settle first because it is heavier than the other rock. In addition, due to pressure, particles that have settled at the bottom of sea would continue to accumulate together until it can no longer do so. And another layer, known as beds, would be formed.
Second thing to remember during the formation of stratified rocks is the law of superposition. The law of superposition states that whenever there is a rock formation, the younger rocks are always at the top and the older rocks always exist below that rock formation. To understand it better, take a look at this demonstration. First thing we put in the glass is the oldest layer. Older rocks are below the ground, while the ones on the top are the new ones. Rock formation or landmass are being created, stacking up until it reaches this peak to where you are standing.
At this point, let's take a look at the final product of our demo. As you can see, a strata is made up of different layers wherein the oldest rock is found at the bottom and the youngest is found at the top. Remember that this is the case when a sequence of rock is not bothered by any process.
It is called the law of superposition. Keep also in mind that a rock layer consists of particles that differ in size, by which heavier materials settle first and then lighter materials eventually settle too.
Now that we have learned how the stratified rocks were formed, now let us find out how we can distinguish its layers. As you probably noticed, layers or bed in a stratified rock don't all look the same. The first thing that defines a bed or a layer of a rock is its color or shade. In this picture, as you can see, the beds are clearly defined by a change in color or shade. A change in color can reflect differences between a bed or a layer. For example, in this picture, this stratified rock has different color or shades, so meaning they are also made up of different layers. Next, we have grain size. Grain size refers to the size and amount of particles that the layer or bed is composed of. For example, if the grain is coarse, the layer it creates is thick. However, if it is fine-grained, its layer or bed is more likely to be thin as compared to coarse grain. But why does it vary in thickness? It is because of the function of the energy of the environment present during deposition. For example, if the size of the grains is larger, it generally indicates low energy and quiet settings during its deposition, meaning they are protected from waves and strong currents. But if it is small grain, there are more energy present during its deposition. It could be caused by strong winds, waves, and other natural environmental factors. Lastly, we have the composition. In composition, there are a variety of factors that influence the composition of sedimentary rocks. Differences in sediment composition results from different sources and variation in sediment. So if there are different composition in a layer or bed, it undergoes different type of mechanisms of erosion and transport. So now that you're familiar with these three factors, which include color or shade, grain size, and composition, you can now distinguish between the different layers or bed in a stratified rock.
Let us now proceed to the importance of studying stratified rocks. The Earth's surface has changed immensely over the past 4.6 billion years. Therefore, most past events are hardly detectable. Stratified rocks are a huge help, as they contain pieces of evidence about the history of our planet. Since these rocks are made of different visible layers of sediments, people are able to identify the respective order of past events. Also, the sediments consist of fossil fragments, which indicate the type of life, environment, and climate that once flourished in a particular area. With that, we can determine the occurrence of past geologic processes like volcanic activities and earthquakes. To put simply, stratified rocks help us to better understand the timeline and existence of life on Earth.
Did you know that sedimentary rocks are the most common type of rock? It is because old rock tend to break apart and become particles that sink to the bottom of the ocean. Due to pressure, these particles accumulate together and eventually form into sedimentary rocks. Furthermore, stratification or layering of rocks occur not only in sedimentary rocks but also in igneous rocks. For example, a volcano erupted and spewed lava and mud flows called lahar. When they solidify, a layer will be formed, and when the volcano erupts again, the process will repeat and will form another layer again.
Whew! What a ride! Stratified rocks go through such a process. We may not be able to witness everything, but we can somehow watch and be part of the process. Stratified rocks basically shows us history. So did you learn anything about stratified rocks? We hope you did. Thank you for watching!